Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap. I'm especially looking forward to this one because there are demos in this one, which always excite me. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded. So if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we will try to get to as many as we can near the end of today's webinar. And we are also at the end of today's webinar going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Automate Your Container Deployments Securely. Our speaker today is Aneel Dadani, who is a technical account manager at Signal Sciences. Aneel, thanks so much for joining me today.
Thanks for having me. I appreciate the time. And yeah, thanks for letting me take today to talk about automating your container deployments securely. I want to thank everyone for attending the webinar, but I also wanted to thank the folks here at Container Journal for letting me speak this morning, afternoon, wherever you are. So today we're going to talk about how to automate your container deployment securely. But first, I'm going to discuss the current trend in the market in terms of delivering applications, how companies are leveraging containerized technology to scale with demand, and scaling in an automated fashion. We will also introduce how automating the delivery of these applications can also include baking Signal Sciences as part of the automated delivery and increase the visibility and protection of these applications. Just to introduce myself, my name is Aneel Dadani. I'm a technical account manager at Signal Sciences. My job is really to help our customers ensure we protect their web applications and API endpoints with Signal Sciences. I'm a board member for the Los Angeles chapter with OWASP and Cloud Security Alliance. And prior to Signal Sciences, I worked at Rapid7, where I helped start the Managed Services department. I hold a bachelor's degree in Management Information Systems from the University of Wisconsin-Milwaukee. And I'm also a CCSK and CKA certified professional. Even though I'm a certified Kubernetes administrator, I still can't tell the difference between starboard and port on a ship. For all you Kubernetes nerds out there. Before I start talking about how to automate your container deployment securely, I want to introduce what Signal Sciences does and how the architecture works. Signal Sciences provides customer application protection that proactively monitors malicious and anomalous web traffic directed at your applications, APIs, and microservices, wherever they run. So it could be cloud deployment, on-premise deployment, containerized, and hybrid environments. Signal Sciences consists of 3 key components: your web or code integrated module, an agent, and a cloud engine for collection and analysis. Our wide array of module options allows flexibility in deployment methods. So this flexibility allows us to scale while keeping our applications secure. Scalability is important because when you look at the market trend for application usage, it's growing, will continue to grow as our lives continuously become more interconnected virtually. The world is doing business on the web. The graph here represents the volume of web requests Signal Sciences has protected. Even prior to 2020, there is a steady increase in web traffic as business is being conducted online. If you think about it, retailers are online, buyers are shopping online, you have various gaming platforms, financial services where you can send and request money, pay bills, trade stocks, media streaming services where anyone can upload content and share it with the world, on-demand services such as food delivery or ride sharing, and even video conferencing for meetings or distance learning, which is probably something we're doing a lot more of right now. And I don't know about you, but I'm sure overwhelmed with how many virtual conferences and meetings I've been attending lately. I feel like I've attended about 2 years worth of conferences and meetings in the span of 6 months. Anyway, my point is, there's an app for all types of products and services that are available at your fingertips. With this ever-increasing demand, companies have to be able to scale. This is why the shift to cloud native is so popular. The adoption of cloud native is expected to rise over the next 3 years. With this adoption, there's the increase in popularity of microservices. We are seeing more and more companies that are refactoring their monolithic applications to microservices. Let's talk about the benefits of moving to a microservices architecture. First off, there's flexibility with hardware requirements. You're able to deploy on inexpensive hardware. There are also managed Kubernetes offerings that don't require you to maintain the hardware at all. You have individual scalability for each microservice. The microservices can be auto-scaled based on demand, so you can add some auto-scaling options there. And there's also minimal downtime or service disruption. You have the flexibility of doing seamless upgrades and rollouts of changes for a specific microservice. This allows each container to run with its own dependencies and libraries, so rolling out those upgrades is a lot easier than a monolithic approach. When we're talking about deploying containers in a large scale, we can use container orchestration tools such as Kubernetes to help manage our containers. In this example, we're deploying a multi-node Kubernetes cluster. The containers are deployed in what's known as a pod in Kubernetes. Just like how we can have 2 peas in a pod, we can have multiple containers running in a single pod. Later on, when we get to the demo, we'll talk about how you can deploy Signal Sciences in a container in reverse proxy mode with the application container in the same pod. With the rise of microservices, we need to be able to secure these deployments. So let's take a look at some examples of vulnerabilities that would affect a typical Kubernetes deployment. Kubernetes environments are famously being hacked to be used for crypto mining. These vulnerabilities here specifically target Kubernetes-related vulnerabilities. These vulnerabilities can lead to data exfiltration, inappropriate access to containers in your Kubernetes environment. And both of these vulnerabilities actually can be remediated by applying the appropriate patches, or they can be mitigated through setting the right security policies and configurations. Now let's take a look at some of the vulnerabilities that are not related to Kubernetes or misconfigurations. An attacker can try to compromise the system just simply by trying to exploit the vulnerability of an application. One of the most popular examples of this was the Equifax breach, where hackers stole sensitive data of over 150 million people. Vulnerabilities like this can go undetected because the patch may not have been applied yet. This can happen for various reasons. There's not enough testing that was conducted for the new patch. The patch was not deployable in production, and it may have could have possibly broken the application in production. And so in order to protect the application, the patch wasn't rolled out to the application itself. Another popular form of attack is SSRF, or server-side request forgery. And this is the type of attack that was conducted during the Capital One data breach in 2019. Both of these attacks are occurring at the application layer and will go undetected at the other layers, which is where a product like Signal Sciences can help. We have rules built to protect against these types of attacks. And I'll show you a little bit of how that can be applied later. I always talk about defense in depth. It doesn't matter how your application is deployed, you want to be able to defend against attacks using a multi-layer approach. When it comes to containers and container orchestration, we'll want to ensure that we are securing the cluster at every stage. Let's start with layer 0, which is your kernel. First and foremost, we want to make sure the kernel versions are patched and do not contain any existing vulnerabilities. We'll want to review system calls and remove any unwanted or unnecessary system calls. We'll want to also run our sandbox containers to provide a barrier between the host OS and the application running inside the container. Next, we'll look at the container layer. In this layer, we're actually looking at during the build process. We want to reduce the attack surface by removing unnecessary components, packages, and utilities. We'll want to use minimal base images. We'll want to scan the images for vulnerabilities and misconfigurations. And keep in mind, there may be times where vulnerabilities aren't mitigated because it may impact production. From a vulnerability management perspective, you'll want to ensure that this is considered and determined as a risk. When possible, consider adding compensating controls as a temporary solution until the vulnerability is remediated. And next, you'll also want to review and approve any images from valid sources. And also check the integrity of the images throughout your CI/CD pipeline and build process. Next, we'll look at the container runtime. At runtime, we'll want to consider using ephemeral containers for live debugging. We can actually hook into your running container and watch for anomalies and suspicious system level events. We'll want to check for any unexpected child processes that are spawned. We'll want to check to see if the shell is run inside a container. And we'll want to know if a sensitive file has been unexpectedly read. Layer 2 is your pod layer. So in terms of your pod, this is going to be a collection of containers. At the pod level, there are additional resources that are available for isolating your pod. Defining the pod security context specifies the privilege and access control settings for a given pod. And the settings include things like privileged containers, group and user IDs for processes and volumes, granular Linux capabilities, sandboxing and mandatory access controls, file system permissions, and privilege escalation program privileges. A pod security policy is a cluster level resource that defines sets of conditions a pod must run in order to be accepted into the system. So for the SSRF CVE we were looking at earlier, that can be controlled by implementing a pod security policy to restrict the usage of the volume. At layer 3, we can create a network segmentation, which is pretty important. By default, pods and containers can easily communicate with each other, which make it easy for attackers to laterally move across the network. This is where network policies can create network segmentation between pods and endpoints in order to restrict lateral movement across containers and pods. One thing to remember is the Kubernetes API is accessible from inside the cluster. So depending on your course, it depends on your service account permissions, but we'll want to make sure that if the service account does not need access to the Kubernetes API, then mounting the creds to the container should be avoided. Network policies can also be used to isolate pods for egress traffic, explicitly allowing and monitoring internet egress to certain pods that actually need it is a recommended approach. And then also, when possible, look at or explore service mesh options. Service mesh is the recommended approach in order to control the traffic between workloads and your ingress and egress. This is fairly new concept for a lot of people, but Signal Sciences has an Envoy and Istio module to support service mesh deployment. At layer 4, we want to protect the nodes themselves that are hosting the Kubernetes pods and containers. So watch out for open ports and services, especially on kubelet. And we want to also limit the external administrative access to the nodes and the control plane. We'll want to make sure that we keep the base OS minimal and harden according to the CIS benchmarks. And you want to scan and patch the node just like any other asset in your environment. Layer 5 is the cluster layer. So here we want to ensure that we're securing the system components of Kubernetes in order to prevent any backdoor access to the cluster. So things like your Kube API server, you'll want to make sure that we're configuring the Kube API server to disable unauthenticated and anonymous access between the kubelet and the Kubernetes API. And additional security checks, such as leveraging image policy webhooks to ensure that unapproved images are not used or enforce pod security policies. Restricting public network access to the API is also an important point. For your kubelet component, you'll want to disable anonymous access to kubelet. And setting node restrictions to set boundaries on what kubelet can access. etcd, you'll want to ensure that etcd is communicating over TLS. For your secrets, you'll want to ensure that secrets are not passed as environment variables and only mounted as read-only volumes in your container. I think that may be a more of a convenient thing to pass secrets as environment variables, but I think it's something that is overlooked at times, but a good thing to keep in mind when we're actually storing secrets. You'll also want to ensure that deployments only have access to the secrets they require. I think that's a pretty obvious point, but nevertheless, a good recommendation. You also want to ensure, obviously, to encrypt your secrets and use RBAC to control access to it. Updating your Kubernetes version to the latest will take advantage of any security patches that are released and enable audit logging. So you're able to identify suspicious or anomalous behavior happening on the cluster, especially when you're using a SIEM. Understand what third-party components are being used in your cluster. So staying on top of any vulnerabilities of those components are important to keep in mind when you're actually patching your cluster. And there are some public cloud options that are available as well. So for public cloud deployments, it's just important to understand how the Kubernetes environment will be hardened from a managed standpoint. You'll want to understand the various support and functionality requirements that come with your managed public Kubernetes environment. So, with EKS and GKE and AKS, like all the different, Kubernetes managed environments, each one has their own feature and functionality. They may have certain container runtime support, or how you access the cluster. Most of them have pretty similar SLA requirements, but how you log and monitor your environment is going to be specific to that environment. And there's just so many different things to consider. But to give you an example, with Google Cloud, if you wanted to choose, using Google Cloud, one of the key features that they have is being able to use Cloud Key Management Service, which allows you to manage your secrets and encrypt data at the application layer. So managing your secrets is a little bit more integrated, and the approach there is different than what other cloud providers are using. So, just to give you kind of an example of how you can leverage your public cloud options and, the kinds of things you may want to consider. This is a checklist of questions to consider as you're thinking of deploying and securing your Kubernetes environment. We talked a lot about all of the different layers that you can protect and ways to protect your containers. But one area that we touched on earlier was identifying an attack on the application layer. Even if we take the necessary precautions to secure all of the layers, a publicly accessible application may still be vulnerable to a remote code execution attempt or SSRF type of attack. If you are interested in getting the full list of questions that we have here, I encourage you to go to our website, signalsciences.com/resources. You can actually get the full list of questions that we cover in terms of securing your Kubernetes application, from all aspects. But yeah, as I mentioned, your Kubernetes environment is going to be vulnerable at the application layer. So where Signal Sciences comes in is with our next gen WAF and RASP options, we can integrate in line with your serverless architecture and protect against application layer attacks. We can actually provide visibility when it comes to business logic attacks or throttle requests using our advanced plan rate limiting, or if you're looking for Apache struts type of attacks, we have the capability to virtually patch your application. So while you're still in the process of validating the patch, we can detect the attack and block the remote code execution attempt. All right, so now I'm going to go into the demo portion of the presentation here today. So I actually have two demos. So the first demo, we're going to kind of talk about how you can use OPA to protect your environment. So a colleague of mine, actually our head of research here at Signal Sciences, he actually did a talk at KubeCon last year. And if you attended his webinar previously, he kind of talked about this before. So he actually has this secure Kubernetes kind of guide in terms of what you can do to protect your Kubernetes environment. So he goes through a set of attack and defense scenarios. And so in this particular use case, what we're doing is we're using Gatekeeper to prevent any, really deny any privileged containers from running in our dev or production environment. So let me go and actually go to my Kubernetes cluster here. And sorry about that, I had to reconnect because it timed out. All right. Okay, hold on. Sorry about that. I had this running already, but it's okay. Cool. So yeah, I've got a running set of containers as part of my deployment. So as you can see here, I've got a dev application and a production application running. And I've actually already gone through the process of deploying Gatekeeper, but we've applied a set of policies for Gatekeeper, so that way when we want to run a privileged container that's not allowed, and this is an example of one where we can try to launch a container, a pod for our dev environment. That's not part of our list of approved images. We're going to going to be blocked. So you can see here that I'm getting that error message that says this is not allowed. And so that's one way where we can secure our deployments, where we can identify the list of images that we will approve or deny. So if I wanted to actually run a pod that was approved, and if you actually look at the error message, you see the allowed repos that are allowed. So I can actually just use one of the items that are on the list that is approved, and you will now see the Ubuntu image that was approved, and it is now running. And if you did want to kind of take a look at this, I encourage everyone to go to this site if you wanted to learn a little bit more about what Jimmy and his team did with this demonstration. All right, so that's our first slide, our first demo. The next one, we're actually going to use an example of a vulnerable web application. We're actually deploying the application in a container within a pod. And then what we're also doing is deploying Signal Sciences in a reverse proxy mode. And what this really does is it will run it as a separate container in the same pod. And so as you can see in this picture here, we have the agent configured to listen on a specific port. And this can be any port you desire, but just for simplicity's sake, I just chose random high number port. And what we're doing is then forwarding that request to the application container. So it does actually pass through the Signal Sciences agent for inspection. I would recommend, if you are interested in learning about how you can deploy Signal Sciences, there's actually several ways you could deploy our agent in reverse, whether it's reverse proxy mode, or if you want to deploy our agent in module. There's several ways to do that. It's actually available here in our documentation. In my example, because I'm using reverse proxy, this kind of actually goes through step by step how you can go about deploying our agent in reverse proxy mode. And so the first thing you'll want to do, obviously, is pull the Docker image, and so that's available. And obviously you probably want to pull the latest image. And we kind of talked about validating your containers before deploying. So if you wanted to keep it in a repository somewhere, you can certainly do that. And then you can continuously update that whenever you're ready to update the image. But essentially what we're doing is we have to actually set agent credentials or agent keys. So what I recommend is to deploy our agent keys as a secret. And we have to have a temporary volume set up. This is primarily so we can use this as a cache volume. So the agent does require some info to be cached. And so this is what we're doing. And also, it's just also for communication for our PC communication. So we'll definitely need access to a volume there. And then depending on how you deploy your agent, you may want to deploy it on a port that is an alternate port from, well, you'll definitely need to use a different port from the application, but if your application is running on port 80 and you want to run the agent on 8080, you can do that. You just want to make sure that the traffic, the request is actually going to port 8080, so that way the agent can inspect the request first. Or you can take the flip side where you have the agent running on port 80 and the application running on a different port. Either way, what you'll have to do is set up the listener and the upstream addresses to ensure that we know what we should be listening on from the signal sciences side and where we should be sending the traffic upstream. So this is just an example of how you can deploy signal sciences in a reverse proxy mode. So I'm just going to show you. So I've got the vulnerable web application running. You may have seen this before. This is the OWASP Juice Shop lab. And what we're actually doing is we're deploying the agent in reverse proxy mode. Let me go ahead and actually go to my signal sciences dashboard. Let me go to the agents page. So you can actually see my agent is deployed. I'm in a reverse proxy mode setting. And I actually have implemented some rules to protect the application from your basic OAuth injection attacks. And so by default, if I didn't apply this rule, Signal Sciences takes a threshold approach, because what we want to do is we want to ensure that we're not impacting your application in a negative way. So we take a threshold approach for these attack signals. And so what we do is if we see 50 of these attacks in a minute, we'll actually then start blocking the attacks. But you have the option of either throttling that threshold down to a lower number, or you can outright detect and block the attack immediately if that's what you choose. Either way, the objective is we don't want to impact your application, and so we'll take, in this particular case, I'm being more aggressive with my detection and blocking, and so I'm going to block the attack right away. So let's see here. So I'm going to, and you can see I have my burp suite running here. I'm going to actually, I got to turn this on, and I got to turn this on. All right, so what I'm going to do first, just to kind of show you how we can detect an account takeover attempt. Actually, let me go back to my 6i dashboard. I also have a set of templated rules that we have configured to detect login attempts. So if I see a certain number of login attempts, I'm going to add what's called a signal to tag the request. And then I've got another signal called login failure, where I identify a login failure attempt, and I can actually rate limit the number of login attempts that are happening. So in my case, I've got a rule set up to detect anytime I see a 401 response, I'm going to consider that as a login failure. And if I see 10 login failures in 1 minute, I'm going to start blocking any login attempts. Let me go back to my login page here. And the first thing I'm going to do, just because I want to identify the trigger an attack signal, I'm going to actually try running a SQL injection attack on this this login page. So I'm just going to try using this example. Let's see. Okay, so I got a login, but it didn't actually like that input. So one thing I noticed is that it kind of triggers. I mean, I can tell that the SQL injection was kind of successful. It just didn't give me the right output that I wanted. So I'm going to just try this real quick. Okay, so now you can see that SQL injection would have worked if I didn't have Signal Sciences enabled and blocking. And so you can see I got a 406 not acceptable response. So let me go to the Signal Sciences dashboard. Let me see what happened there. Okay, so I can see that the attack occurred, or it saw the attack, from the login page, and it actually blocked it. Now let's say, for example, I go to one of the products page and I see that we've got a person that reviewed the product. I actually have the person's username, so now I know that this user is available to possibly log in with. So I'm going to actually go to the go through the process of trying to log in as this person. All right, and then so I'm just gonna actually. I mean, you're probably gonna have a more sophisticated attack than what I'm showing here, but I'm just kind of showing you how we can identify a certain, a brute force number of attacks. Let's see. Oh, no, I don't want that. Sorry. Okay. Oh no, sorry. Let's see. I had a custom list, and I apologize. It's not here. Because I had to start over. So let me just do that.
While Aneel is working on that, I do want to quickly remind the audience that today's event is being recorded and we are taking questions from the audience. So if you do have a question for Aneel, go ahead and use your GoToWebinar control panel and submit your questions, and we should be getting to the question and answer period probably within about 10 or 15 minutes or so, and we'll be happy to get to all the questions at that point.
Thank you. All right, yeah, so sorry about that. I got the attack working. So now it's just iterating through various options. I mean, like I said, you're probably gonna have a more sophisticated attack than this, where you may have like a custom list of passwords that you want to kind of page through. So in this case, I'm just kind of making it really simple, but you can see that I'm getting some login failure attempts. And eventually this should get to a point where I start to see some 406 responses. And so what ends up happening is when we see the number of login failures, we're going to now limit that. Yeah, you can see here, I got the 406 now. We're now limiting the number of login failures that are, or login attempts actually, by this IP address. So you can see now that this is where you determine when an event has occurred. So this particular requester has been flagged now for too many login failures. And so now we're going to start blocking login attempts from that user. And so you can see I'm going to continue to get a 406 response until either that IP falls off the block list or we allow it. And let me just go ahead and actually go to the request page, and you'll start to see those blocked attempts. All right. And that wraps up the demonstration. I'll go ahead and open it up for questions.
All right, guys, as I said before, plenty of time for questions. We have about 15, almost 20 minutes for questions. So if you do have a question for Aneel, go ahead and use your GoToWebinar control panel and submit your questions. let's go ahead and dive right into the ones we've gotten so far. If Signal Sciences can inspect encrypted traffic, can it do that in a container pod as well?
Yes, absolutely. Yeah. So depending on your architecture, if you do take the module and agent approach, you may already be able to, identify, like you're probably already getting the encrypted traffic and decrypting it on your web server. So for example, if you're using Nginx, you may already be using that. And so you could use our module agent to inspect the traffic that way. Or if you use our reverse proxy, we have the ability to inspect the encrypted traffic. We would just need the certificates to be able to do that.
Okay, great. Next question here. For layer 1, how do I know an image source is trusted? Do we just go to known sources like Docker Hub?
Yeah, I would recommend, Docker Hub is a good place. When you actually search for images in Docker Hub, you can choose whether or not there's like the certified image or, like I think it's the Docker certified image. You can use that. Docker Hub actually just added some functionality to be able to let you scan the image. So there's some functionality there. There's other tools out there too that are pretty much available. There might be some open source options and also some enterprise options that let you scan your images and validate whether or not it's acceptable for your environment.
All right, excellent. Excellent. Once again, guys, we have lots of time for question and answer. So go ahead and get your question in if you have one. Next question here, let's see. Okay, here's one for you. Any overall guidance you can provide for pod security policy if we'd rather do it ourselves versus open policy agent? And what are the pros and cons of each approach?
Yeah, so I would say that for pod security policy, if it's a situation where you may feel like you may be more comfortable with doing it yourself and setting your guidelines, that's definitely probably a more controlled approach that you as a security professional you may want to take. But I think using a third-party tool like what we just saw with Gatekeeper definitely makes things easier. I think in a complex environment, you try to want to keep it as simple as possible. So that way there's less possibility of breaking something. But yeah, no, I think it's a good idea. Like if you can, maybe a good idea to use third-party tools like Gatekeeper to be able to set your pod security policies versus kind of doing it yourself.
All right.
It saves time.
Great.
Like I think everybody would like that.
Okay. All right. Let's see. Okay. Does reverse proxy include the web application firewall, WAF?
Yes. So the reverse proxy is essentially your WAF. So think of it when you're talking about a traditional WAF where you have a physical appliance, you put it in your data center, and all of your web traffic goes through that appliance. It's kind of like that, but our reverse proxy can be deployed within your pod. And so you could essentially allow us to scale with your pod. And so you don't actually have a bottleneck when it comes to the WAF that we're providing versus a physical reverse proxy WAF appliance.
All right. Cool, cool, cool. All right, let's see. So many great questions. How about, okay, here's one for you. Regarding the network layer, what are some tools available for monitoring traffic between pods or clusters? Can IDS/IPS like Bro or Suricata be configured to do this?
Yeah, so I think, when we're talking about monitoring traffic between pods and clusters, you could certainly use tools like Bro or Suricata to do that. But if you think about the type of traffic that's happening between pods and clusters, especially in a Kubernetes environment, everything is happening through the Kubernetes API. And so you could actually deploy Signal Sciences within your Kubernetes ingress controller. And so there's ways for us to actually deploy in that method. I kind of showed earlier our documentation. So one of those examples is using Signal Sciences to deploy us in the ingress controller. But yeah, I mean, like if you're looking at monitoring network packets, then the best option would, you're probably already using something already. So it's probably a good idea to just ensure that you kind of rope that into your Kubernetes cluster. But if you're not, then I guess it's just a matter of evaluating what makes sense for you. I know people like to use Splunk, and they'll use syslog for monitoring their network, or if they're using Elk for their SIM, they'll forward syslog information, or they'll do like packet captures with I don't know if they're you could be using Bro, or you could be using another tool to do that, and essentially forward that to your log aggregation.
All right, great. I think we have time for maybe 2 more questions here. So let's see, here's, okay, let's see, so many great questions. Okay, here's one, layer 6. We're in AWS, we're a small team. Do you recommend AWS tooling to stay secure? I'm thinking of something like CloudTrail, but do they have Kubernetes specific security tools?
Yeah, so CloudTrail is definitely a good option. I myself have used AWS for my own stuff, and CloudTrail is very effective. And I think that's probably a good option. But in terms of any Kubernetes specific security tools, the challenge with AWS is that it's kind of like there's all these options, and then you get to pick and choose what you want. I would say if you're simply just using it to understand how to secure your information, I would direct you to our questionnaire, just so you can really look at all the things you want to consider when it comes to actually exploring all the various options. It's probably also a good idea to review the AWS documentation in terms of what sort of options there are. I feel like they're releasing new stuff almost every day in terms of what they're doing to provide more secure options for deploying your Kubernetes cluster. But yeah, I think using our questionnaire and reviewing the AWS documentation on how you can leverage some of these capabilities is probably a good idea.
All right, great. So let's throw one more question at you, and then we'll call it a day as far as the Q&A is concerned. Okay, do you have any automated tooling suggestions for checking the integrity of images throughout the CI/CD pipeline?
I always use the word or the phrase "it depends" because I don't know if it I would say it depends because of the fact that everyone has kind of their own preference when it comes to using CI/CD pipeline tools. I mean, I've been kind of messing around with Circle CI a little bit. So I mean, I think it just depends on your amount of resources you have and whether or not it works for your environment. But you know, something to think about maybe is exploring with open source tools first, just to kind of get a feel for it. And then if it makes sense, you know, then you could possibly leverage those open source tools. And then if, you know, some of them may have enterprise options too. So if you need to upgrade to get some additional features and things like that, if that makes sense for you, then yeah, perfect. But if there's all sorts of stuff you can probably find online that provide open source, you know, CI/CD capability.
All right. All right, well, let's go ahead and close out the question and answer period now. We went through some really great questions. I'm going to keep the question panel open, though. If we do get any last minute questions, I will kind of throw them your way, Aneel. But even if we get any and we're not able to get to them during the webinar, please know that the folks at Signal Sciences are getting a copy of all the questions that come in. So I'm sure will be more than happy to follow up with you offline to get your question answered. Also want to remind the audience real quick that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, watch those demos again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the Container Journal website, so you can always go look for it there. Just go to containerjournal.com/webinars, look in the on-demand section, and it will be right there waiting for you. All right, I also noted at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is Mason B. Congratulations, Mason. Our second winner today is Sandy T. Congratulations, Sandy. Our third winner is Stephen L. Congratulations, Stephen. And our final winner today is Andre P. Congratulations, Andre. We'll be following up with all 4 of you offline via email to get your $25 Amazon gift card over to you. So if you don't see anything in your inbox, please check your spam folder. Okay, guys. Aneel, thank you so much for a great presentation. It was really fascinating to see, especially the demos. I don't think I explained how much I enjoy watching the demos. So thank you for including them, and lots of good stuff.
Of course.
I think it's always the best way to learn about things is to watch the demos. You see it in action. So thanks again for that. Really appreciate it.
Of course. Thank you for having me.
Absolutely. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.
Thank you. Bye-bye.